Okay, here we go. Last screencast. Okay. This last part here is how do we calculate or figure out what delta H is numerically. We've talked about how you can use evidence about whether the surroundings get warmer or colder to identify the sign of delta H, but how do you know the number, the numerical value of it? So one way is you can use, you could measure it in an experiment, which would involve using a calorimeter. Calorimeter. I think some of us are still having a hard time saying that. Okay. There's also two different other methods that we'll use. So Hess's law and heat subformation. So we're going to do this part in class. Hopefully we've already done that and it made sense to all of you completely. But if not, here's an example. So, okay, it says write out the reaction that shows the dissolution, which means dissolving in water, of sodium hydroxide, which is NaOH. Oh man, and water. Okay. So you can write, okay, include states of matter and show aqueous species separate. Okay, so we're going to write Na plus aqueous plus OH minus aqueous. Okay, so looking at this equation, without reading the second part of the equation, are we able to tell just from the equation what the sign of delta H is? No, very good. Okay. If we read the next part, because it could be endothermic or exothermic, dissolving in water. Okay. If we read the next part, it says a student dissolves 4 grams of NaOH in 100 mils of water. That is at 18 degrees Celsius. The temperature of the solution rises to 28.7 degrees. Caddy, are we now able to tell whether it's endothermic or exothermic? Yes. Good. And Aiden, is it endothermic or exothermic? Good. You guys probably couldn't hear that, but he said, well, the temperature of the water got warmer, so the reaction released energy, which warmed the water. Therefore, it was exothermic. Very good. Thank you. Okay, so based on that, Rhea, will delta H be negative or positive? Rhea says it'll be negative, but she is right. Exothermic means negative. Okay, so we're trying to find delta H, and delta H is basically some number of kilojoules per mole of NaOH that reacted, okay? Or per mole of Na plus that formed, or per mole of OH minus that formed. Remember, it relates, it's sometimes called mole reaction, like that. And it relates to, like, the number in front would represent the coefficient. The coefficient would represent the number of moles that this relates to. That's a little confusing. Anyways, if this was a 2, then it would instead be kilojoules of heat released for every 2 moles of NaOH that reacted, but it's just 1. Okay, so this is a calorimeter experiment, so if it helps you to draw a cup with water in it, you are sure welcome to do that. The most important thing is, for calorimeters, we need to use Q equals MCAT. Okay, so 100 mils of water is how many grams of water, Owen? 100 grams of water. Easy question. Okay, so 100 grams of water has 4 grams of solid go in. I'm going to show little dots of solid that go into the water. Okay, the initial temperature is 18 degrees. The final temperature is 28.7. Okay, so our first step here is we want to find the heat that the reaction released. Again, it released because the water got warmer. Okay, so we're going to plug in. So our question here about mass is, do we just want to use the mass of the water, or should we also include the mass of the NaOH? Michelle, do you have an opinion about that? She does. She says we should include both. I agree with that. Preeti, do you have an opinion why? Preeti says because they both started at room temperature or about 18 degrees Celsius and they both absorbed the heat together. The NaOH that got dissolved in the water also got warmer along with the water itself. That was, yeah, good explanation, Preeti. Hers was better than mine. Okay, so we're actually going to do the mass of the solution. With the metal in the lab, we didn't include the mass of the metal with the mass of the water. Sonia, why was that? Yeah, good, Sonia, because the metal underwent a different temperature change from the water. Like the metal got colder and the water got warmer and they met at the same final temperature. Whereas in this case, they're both starting at basically room temp, maybe it's a cold room, and they're both getting 10 degrees warmer together. Okay, so we're going to say 100 plus 4. And with sig figs, what do we end up with? Milan? Good, 104.0. Okay. Period A is really killing the questions today. Oh gosh. Okay. So the specific heat of water, we're going to assume is the same as the specific heat of the solution. Okay. Because it's mostly water. It's like 98% water or something. So it's basically the same. Okay. Our change in temperature, we're going to do final minus initial. And sig figs, we're going to have 10.7, right? Okay. So it's 4,656. So sig figs, Monet, how many sig figs should we have? 3. Yeah, good, because our temperature change was 10.7. Okay, 3 sig figs, 4, 6, 60 joules. Okay, so we just found out part of this equation. This equation up here, we're trying to find the amount of heat released per mole, right? I'm actually going to write that down here. Delta H is going to be equal to heat per mole, okay? The tricky thing here is that we just found this in joules, and we need to plug it into delta H in kilojoules, so it helps to convert it. We might as well do that now, okay? Okay, so the last thing we need to do is say, okay, 4,660 joules of heat was released when that amount of sodium hydroxide dissolved, but it wasn't a mole of sodium hydroxide, so we need to standardize it to a mole. So how much of a mole was it? Okay, so we want to say 4 grams. We're going to divide by molar mass. I should know this one, and I don't. So Google to the rescue. Oh, it's 40. I knew that. Okay, 40.0. 0 actually, grams per mole. Okay, so this was exactly 1/10 of a gram. So, Ayush, how many sig figs? 2 sig figs, 0.10 moles. Okay, so I didn't leave very much space for myself here. So we're basically ready to do our equation for delta H, which is kilojoules divided by moles. Okay, so we're going to do a negative 4.66 divided by 0.10. Okay, 46, and also we should only have 2 sig figs. Okay, so that's our answer, negative 46 kilojoules per mole. So that's what you did in class. Hopefully it went okay, and if it didn't, hopefully this helps. So the key things here that are mistakes that are common is it should be the mass of the solution, the whole solution. I guess highlight's not working. That's fine. That's fine. Oh well. It should be the mass of the whole solution. We need to convert joules to kilojoules. We need to be careful that the sign matches the data that we got, like that the reaction was exothermic. And we need to divide by moles. Yep, that's all dissolved. Okay,